about 150 to 250 million light-years away, in the direction of Norma, something massive is bending the motion of our galactic neighborhood. We cannot see it cleanly because the Milky Way itself blocks the view with dust, gas, and crowded stars. The motion shows up when galaxy velocities are compared carefully. Galaxies around us share a drift that points toward the same obscured region, as if the local universe has a current running through it. This shared current becomes the clue behind the Great Attractor. Stay with this investigation as the Great Attractor turns from a hidden anomaly into a map of where our galaxy is going. The mystery is not a monster object waiting in the dark. It is a question about mass, motion, and why the largest structures in space can guide us without ever shining. By following velocity instead of appearance, astronomers began to map an invisible direction. To understand the pull, astronomers first had to separate ordinary expansion from galaxy motion. In an expanding universe, distant galaxies generally recede, but nearby systems also carry peculiar velocities, extra motions caused by local gravity. The velocity map did not look random once it covered many galaxies. The Milky Way, nearby groups, and surrounding clusters appeared to share a drift toward the southern sky. The difficulty was that the direction passed through the Zone of Avoidance. This is the band where our own galaxy hides background space behind dust, gas, and dense star fields. Visible light surveys saw a gap, not because the region was empty, but because the foreground was too bright and crowded. Infrared and radio surveys changed the map. The newer surveys revealed galaxies, clusters, and filaments where older charts showed only a blind spot. The Norma Cluster, also called Abell 3627, became the clearest landmark in that hidden zone. It is rich, massive, and close enough to matter, but it still does not explain the whole flow alone. A single cluster can mark a direction, but gravity adds up through everything around it. Companion clusters, sheets of galaxies, and matter that does not shine. Scientists treat the Norma Cluster as the best visible signpost, not as the full answer. This makes the evidence stronger, not weaker. The signal comes from motion measured across many systems, from an entire pattern of movement rather than one dramatic image. The Great Attractor is therefore best understood as a gravitational region inferred from how galaxies move when light cannot tell the whole story. Laniakea then widened the frame for the entire mystery. In 2014, astronomers used galaxy velocities to trace a vast basin of motion. The result was a supercluster containing the Milky Way and roughly 100,000 galaxies across hundreds of millions of light-years. In that map, the Great Attractor is not the end of the story. It is part of a larger downhill pattern in space, where galaxies move along filaments toward shared gravitational basins. Tell us in the comments which clue about the Great Attractor feels most convincing so far. This is where the mystery becomes more elegant. Cosmic flows do not point to a single cosmic drain. The flows reveal relationships between clusters, dark matter, and the web of large-scale structure. Laniakea gives our neighborhood a boundary based on motion rather than a line drawn on a telescope image. It shows that the Milky Way belongs to a moving community, not an isolated island. The word supercluster can sound like a label pasted on the sky, but here the label comes from measured movement. Galaxies on one side of the boundary flow one way. Galaxies on another side belong to a different basin. The Great Attractor helps organize that movement, while nearby filaments and unseen mass explain why the pull reaches beyond the Norma Cluster itself. That distinction keeps the story scientifically honest. We are not falling toward one visible target. We are moving inside a gravitational landscape that can be measured only by comparing distance, redshift, and direction together. The map is dynamic, and every galaxy velocity adds another trace to it. The remaining mystery is a question of scale. The Great Attractor is real, but its borders are not as clean as a planet or a star cluster. Some of the mass is hidden by the Zone of Avoidance. Some of the motion points beyond the nearby region toward larger concentrations, such as the Shapley Concentration. That does not erase the Great Attractor. It places it inside a deeper chain of large-scale structure. Astronomers test that chain by measuring more distances, correcting for foreground dust, and comparing independent surveys. Each improved catalog turns the pull from a dramatic phrase into a more exact map. The gravitational anomaly becomes less supernatural and more interesting, because the invisible part can be weighed by its effect. Dark matter, galaxy clusters, and filaments all leave signatures in motion. Hidden structures bend routes without announcing themselves as bright objects. That is why the strongest version of this story is not about fear of being dragged somewhere. It is about learning that motion is evidence. The Milky Way is traveling through space at hundreds of kilometers per second relative to broad reference frames. Yet that speed is not chaos. The speed belongs to a wider gravitational pattern. The question is how much of that pattern comes from the Norma region, how much comes from wider structures, and how future surveys will separate the two. New infrared maps, redshift surveys, and distance catalogs make the hidden region less opaque with each pass. New maps do not remove the mystery. Better maps sharpen the question into something scientists can test. By the end, the Great Attractor is not a solved object with a neat edge. It is a proven direction with unresolved depth. The Milky Way is moving with a larger current shaped by mass we can only partly see. The hidden sky near Norma is one of the places where that current becomes measurable. The Norma Cluster, Laniakea, the Zone of Avoidance, and dark matter are not separate mysteries thrown together. Together, these clues become different windows onto the same problem of gravity organizing our cosmic neighborhood. Subscribe to keep exploring cosmic mysteries and deep space documentaries, and stay curious about what gravity is still hiding. The payoff is quiet, but the implication is enormous. Space is not a static backdrop around us. It is a layered structure, mapped by light where light escapes, and by motion where it does not. What began as an odd drift became a method for reading the unseen architecture of the universe. That is the emotional center of the documentary. Not doom, but orientation. We are learning where home is moving.